All right, in this lesson, we're going to be looking at graphs of proportional relationships and also graphing them to see what we can learn about them. So we'll go ahead and get started. So we're going to determine if the relationship shown in the table, start off with looking at the table, which is what we're used to. So we determine if the relationship shown in the table is proportional, and then we're going to graph each point or ordered pair in the coordinate plane. We're going to connect to try to make a straight line, and we're going to continue our line through the points through the y-axis. Basically, what we want to do is make sure that our line touches the y-axis. And here's the y-axis is this line right here, okay, going straight down. All right. Now, with that being said, let's go ahead and how can I get this off? We'll go ahead and look at these and see if they're actually proportional. All right, so to determine if they are proportional, you take y and divide it by x. We're going to take y and divide by x. So take 4 divided by 2, we get 2. In this column, not 3. But you would take 6, because it's y divided by x, divided by 3, and we get 2. And this column, we're going to take 4. I keep saying column, it's row. Not 4. I don't know why I'm putting that. Bear with me. Having a moment. Or 2. Take your y, which is 8. Take 8 and divide it by 4. You also get 2. Take 10 divided by 5. You get 2. 12 divided by 6. You also get 2. I'm going to make this look a little better because I don't like the way it's looking. That was 10 divided by 5. All right, so if you'll notice, you constantly get the number 2. So yes, this is proportional. The constant of proportionality, which we call K is equal to 2. And then to write the equation, you write it in the form y equals kx. And we're going to replace K with the number 2. So we have y equals to 2x. If you hear that noise, I'm making coffee, sorry. So y equals to 2x is the equation. All right, so we've done those things. Now we want to take a look, and we're going to graph. So we're going to graph the order pair 2, 4. 2 is an x, 4 is a y. So since 2 is an x, go to 2 on the x-axis. So we'll start on the x-axis first, go to 2. And then you want to go up to 4. Go over 1, 2, and up 1, 2, 3, 4. And you're going to put your point here. 3, 6 means go to the right of 0, 3. Go to the right of 0, 3. And then up from 3, 6, 5. So there's 3, 6. 4, 8 means go to the right 4 and up 8. 5, 10, go to the right 5 and up 10. 6, 12, go to the right 6 and up 12. Now, the one thing I have noticed students make a mistake with is they will, because the constant of proportionality or unit rate is y divided by x, some students will start off by plotting the y and then plotting the x. No, although the constant of proportionality is found by dividing y by x, plotting a point is just the opposite of it. It's not y before x, it's x before y when you plot a point. So make sure you start off with your x value first. Okay? Then your y value is second. So again, it's the opposite of the unit rate or the constant of proportionality. All right, now let's make a line. Let's see if I can make this line correctly. So we got shapes on here. All right, there's my line. Okay, I'm going to start up here. Okay. We'll start there, and then we'll just make a line. And we're going to go all the way through the y-axis till it touches the y-axis. Okay, it touches the y-axis right there. All right, so I've done everything for number 1. So now I just move on to number 2. Number 2, first of all, we're going to determine if it's proportional. So we'll start off with y. Again, y divided by x. So we'll take 6 and divide it by 1. We get 6. Take 8 and divide it by 2. Sometimes it writes right and sometimes it doesn't. Take 8 and divide it by 2. We get 4. Well, I can automatically tell you it's not proportional. So since it's not proportional, we're going to skip this part and skip this part. We're not going to do it because it's not proportional. And you all haven't learned how to write equations for non-proportional relationships yet. Matter of fact, you won't learn it until grade 8. All right, but we're going to go ahead and plot what we have. So I'm going to plot 1, 6, or graph these points. That's to the right 1 and up 6. 2, 8 to the right 2 and up 8. 3, 10 to the right 3 and up 10. 4, 12 to the right 4 and up 12. And 5, 14. My graph is going to be a little off, but it will be somewhere up here, okay? All right, so I'm just going to take the points that are actually on the plane and connect those dots, those ordered pairs. All right, so we'll start right here. But we're going to keep going until it touches the y-axis. Okay, it touched the y-axis. Okay, I'm going to stop right there. All right, so with that being said, we don't have to worry about the other part. We'll move on to number 3. All right, so let's move on to 3. On 3, let's determine if it's proportional. Again, take y and divide it by x. So 2 divided by 3, I'm going to leave it as that because if I divide 2 by 3, I'm going to end up with some repeating decimal. Actually, it's going to be 6/10 repeating. So I'm going to leave this part as a fraction. Now you can change it to a decimal if you want to, but again, it's going to be in repeating form. And that's already simplified. So the 2/3 is already simplified, so I'll leave it. Then I'm going to take 4 and divide it by 6. Well, that's not simplified. It simplifies to 2/3. I'm going to take 6 and divide it by 9. I can simplify those by dividing them both by 3. That's still 2/3. These up here, I divided them both by 2. All right, here I'm going to take 8 and divide it by 12. Divide both of these by 4 and see what it simplifies to. Well, they simplify to 2/3. So everything simplifies to 2/3. So this is proportional. So K in this case is 2/3. And the equation is written in the form y equals to kx. So K is 2/3. So when I get ready to write the equation, it comes out pretty easily. Y equals to 2/3 x. That's the equation. Now I'm going to graph. So if I graph this, 3, 2 to the right 3 and up 2. 6, 4 is to the right 6 and up 4. 9, 6 is to the right 9 and up 6. And 12, 8 is to the right 12 and up 8. All right, I'm going to connect these using a line. And I'm going to make sure my line touches the y-axis. Okay, it touches the y-axis right there. All right, now let's move on to the next one. Let's just check to make sure each. I don't want to do that. Let's undo that. All right, so there's my undo button. All right, let's get the drawing back. So let's check to make sure that each y divided by x is constant to see if it's proportional or not. So this is a y of 1 divided by 3. Okay, if I divide it, I'm going to end up with some decimal that repeats. I'm going to leave it as a fraction 1/3. Then I'm going to take 2 and divide it by 4. Well, if I simplify that, it ends up being 1/2. Well, 1/3 is not the same as 1/2, so it's not proportional. Therefore, I'm not going to worry about that or that, okay? But I am going to graph. 3, 1 is to the right 3 and up 1. 4, 2 is to the right 4 and up 2. 5, 3 is to the right 5 and up 3. 6, 4 is to the right 6 and up 4. So I'm going to take those and graph that. I'm going to keep graphing until, draw my line until my line hits the y-axis. Okay, hit the y-axis right down here at -2. All right, so let's take what I have and see if we can answer some of these questions. It says, what do you notice about the graphs of proportional relationships? So I think we only had 2 of these that were proportional. So let me see if I can slide back to them. Oh, I keep drawing lines. Okay, let me undo. I don't want to keep drawing lines. Okay. Let me draw that line back. Let me put this one back. Okay, make sure I get it off the line. All right, let's go back up here and see what we get. It's much easier if I do it this way. So number 1 was proportional. Okay, so look at it. Just look at the graph now, okay? So we're only looking at this part right in here. All right, so if you look at this graph, what do you notice about the line? Well, the line is a straight line, okay? But it also touches this is called the origin. It touches 0, 0. Okay, let's see if the other one is a straight line that touches 0, 0. Okay, so let's go look at this other one. This one, number 3, was proportional. Well, it was a straight line, and what did it go through? It also went through the point 0, 0. I don't want to copy anything. Okay, so it went through the point 0, 0 right here. And let's take a look at the other ones, the non-proportional ones. It was a straight line, but what didn't it do? Well, it was a straight line, but it didn't go through 0. It didn't touch down here. This was a straight line, but it also did not touch at the origin. So it's important to see that if it's proportional, it's got to be a straight line and it has to touch the origin. All right. Straight line and touch the origin. So we're going to go ahead and make those comments down here. And like I said, if you're taking notes, make sure you're pausing the video and taking the notes like you're supposed to. The graph of a proportional relationship is a straight line that passes through the origin. All right, so as long as it's a straight line and goes through the origin, then that graph is a proportional relationship. All right, so let me give you some that are not proportional. Graphs that are not proportional. Okay, so let me make a coordinate plane. All right, so suppose my coordinate plane, that was y, and this was x. Now, if we had something like this, let me do it in black. It's touching the origin, but I'm not going to make it straight. So just because it touches the origin doesn't mean it's proportional. It's not a straight line. It's got to be 2 parts. It's got to be a straight line and it has to touch the origin, okay? So don't get tricked by those that look like that. All right, that's the x-axis. That's the y-axis. Let me see if I can think of another one. Something that looks like this. It's a straight line, but it doesn't touch the origin. It touches, well, the origin is right here. So that's down here is 0, 0. Okay, this is the origin, but it doesn't touch it. So again, it has to be a straight line and it has to touch the origin. So this is not proportional. All right. Let's go to the next page. All right, the next page says the cost of renting video games from Games Incorporated is shown in this table. Determine whether the cost is proportional. So we're going to look at see if the cost is proportional to the number of games rented by graphing on the coordinate plane. So all we want to do, I know we can determine by dividing our y variable by the x variable. So we can take cost and divide it by the number of games if we wanted to determine if it's proportional and check each one of those to see if that constant was the same. But we want to do it by graphing. So we're going to graph these and see if it's proportional. So I'm going to go ahead and graph 1, 3 to the right 1 and up 3. All right, I'm going to graph 2, 5 to the right 2 and up 5. 3, 7 to the right 3 and up 7. 4, 9 to the right 4 and up 9. And I just want to graph to see if it's going to touch the origin. I know it's going to be a straight line. All right. Looks like it touches the y-axis right here. I know my line is a little off, but just pretend it's straight, right? Like up here at the top, it's not. All right, so it touches at 0, 1, not 0, 0. So automatically we can write that this is not a proportional relationship. Like you don't have to do the math part where you take y and divide it by x for each one. You can just graph it and see if it's a straight line that goes to the origin. To me, it's actually less work when I graph it and see if it goes to the origin. Okay. Let's take a look at 2. Let me undo that because I'm not trying to draw. Right, if I take a look at 2, it says the slowest mammal on the earth is a tree sloth. It moves at a rate at 6 feet per minute. Determine whether the number of feet the sloth moves is proportional to the number of minutes it moves by graphing the coordinate plane. And then we're going to explain our reasoning. So again, I don't want to divide. I don't want to take a y and divide it by an x. I want to look at the graphs now and determine if those graphs represent proportional relationships. So 0, 0. In 0 minutes, it doesn't go anywhere. Okay, in 1 minute, it goes a total distance of 6 feet. In 2 minutes, it goes 12 feet. So I plot the point 2, 12. In 3 minutes, it goes 18 feet. So I plot the point 3, 18. And in 4 minutes, it goes 24 feet. Four 24. Now I'm just going to make a line. And let's see what happens here. And as you can see, it touches the origin. Okay. So just by looking at the graph, I can say that it is proportional. So when it says determine whether the number of feet is proportional, I'm going to put yes. It is proportional. Okay, so like why is it proportional? Just by looking at the graph. Because the graph is a straight line that goes to the origin. Or I can put that touches the origin. That's why. Okay, all right, let's look at this last part. So we're going to identify the constant of proportionality given a graph, or I'll call it unit rate. It's the same thing. So you should know how to find the unit rate or the constant of proportionality from a table. From a table, you take y and divide it by x. From a word problem, you might look at what's dependent. The dependent one is y, the independent one is x. Still take y and divide it by x. It might be a rate statement in the word problem. You still take y and divide it by x. You might see a measure of time in the word problem. Every measure of time is going to be represented with the variable x, still y divided by x. Okay, but for this lesson, you learn to check to see if it's proportional from a graph. If your graph is proportional, or your table or whatever, the equation or whatever statement they give you, if it's proportional, all you have to do is plot the points and see if that graph is a straight line that goes through the origin. You've also learned to tell if equations are proportional. Equations are proportional if they're in the form y equals to kx. If it has something like y equals to kx plus some number, it's not proportional. Or y equals to kx minus some number, it's not proportional. All right, but for right now, what we want to do is I want to give you a graph, and I want to see if you can tell me what the unit rate is or the constant of proportionality is from that graph. So we're just going to find k from this graph. All right, so the constant of proportionality is always the point 1k. Okay, and I'm going to tell you what that means. An ordered pair consists of an x and then a y. Okay, this is what an ordered pair looks like. Okay, so if you have 1k, that 1 is like your x, and y, and maybe I need to do this the other way around. Okay, let me switch this around. Undo. Okay, all right, so let's do it this way. All right, so this 1 has to be an x coordinate. So if you have an x coordinate of 1, then your k, or your constant of proportionality, is whatever your y variable is. Okay? Let me put that back. So let me just give you an example. So if you had an ordered pair, maybe it was 1, 5, you got an x value of 1, your y value is your constant of proportionality. So here the constant of proportionality would be 5. Or if you had something like, let's see if I can get more room on here. Or if you had something like 1, I don't know, 1, 8, it doesn't matter, I'm making up something. You got an x value of 1, so this y value is your k, so k is 8. All right, so I hope you see what I'm talking about. If you have an x of 1, an x value of 1, that y value is your constant of proportionality. All right, additionally, what you can do, says additionally, you can find the constant of proportionality by finding the ratio of what? Well, two things. The ratio of y and x, which is y divided by x. Let me see if I can make that look better. For any point on the graph or the line, okay? All right, so if you can pick a point on the line, all you have to do is take your y coordinate and divide it by your x coordinate. So it's two options. Two options to finding the constant of proportionality from a graph. Okay, so let's look at option 1. Option 1, let's see if I have an x of 1. So if I take a look, here is an x. Let me see if I can get a highlighter on here. There we go. Here is an x as a coordinate that has an x of 1. Okay? So since this coordinate has an x of 1, I'm going to pick it out. All right, I don't want green. I want black. All right, 1, 2. There's your x of 1. So this y value is your k. So I know k is equal to 2. I don't know why it's writing like that. Let me try it again. K is equal to 2. In other words, your constant of proportionality is 2. All right, now There is another way of finding it, okay? Or this is the other option. This is option 1. It's just look for a coordinate that has an x of 1, and then the y value becomes your constant of proportionality. All right, so the other option, I'm calling it option 2, is to pick a point, pick any point, and divide y by x. That's option 2, okay? Option 1, again, was look for an ordered pair with an x coordinate of 1. I want to write it right there. Okay. All right. So if I just go back to option 2, pick any point and divide y by x. So I'm going to label these. Every ordered pair consists of an x and then a y. So I could have taken any y and divided it by an x. So like if I look at this point, 3, 6, I can take 6 and divide it by 3, I get 2. Or I can take, for this one, this 2, 4, I can take 4 and divide it by 2, I still get 2. You can also do it with this one, whether you have an x of 1. If I do it with this one, I can take 2 and divide it by 1, I still get 2. Okay? And it's 2 what? Okay, so I'm going to show you something. So I know that k is equal to 2. And you'll say, well, 2 what? If I want to attach meaning to it. Remember, the y value was in the numerator. It came first. So what's on the y-axis? Well, the y-axis is talking about money. And the x-axis is talking about number of sodas. So if I got k by dividing y by x, and let me write this like this. Y by x. Y is your money. X is your number of sodas. Okay? So this 2, so if k of 2 is just $2 per soda. That's all that means. All right, that's your constant of proportionality. And again, you can use 2 options if both of them will work. Option 1, look for an ordered pair. Option 1, you're going to be looking for an ordered pair of this part right here. Look for an ordered pair with an x coordinate of 1. Okay, there's an x coordinate of 1. Or option 2, pick any point and divide y by x. So that works for any point. You don't have to pick all of them, just pick one. All right, let's move on to this one. Walking speed. We're talking about walking speed. So I'm going to go ahead and write the units. I know the y value is talking about miles. Okay. And I know that the x value is referring to hours. So I got my 2 units. It's miles. It's going to be miles per hour when I get my answer, okay? All right, so I'm going to see if I can use option 1. Well, option 1, do you see an x value of 1? Well, there's an x of 1, but can you tell what this is? Here's my x of 1. My x of 1 is right here. if you can name that point without estimating or guessing, then use option 1. Well, I don't know what this y is right here. Okay, it looks like a half. I'm not quite sure. So, I would have to guess it. I don't want you guessing. So, option 1, don't use option 1 on this one. Don't look for an x of 1 because you can't really tell what the y value is. All right, so I'm only going to use option 2. I'm going to divide y by x. I'm going to pick a point. All right, so I'll pick any point you want to. So I'm going to pick this point. All right, so let's label this point. This is the point to the right 2, and put your x before your y, and up 1. So when you divide, put your y before your x. So your constant of proportionality is just 1/2. 1/2 can be changed to 0.5, or you can just leave it as 1/2. It doesn't matter. I'm going to leave it as a fraction. Now, I could have chosen this point. Let me do it in different colors. So if I chose, let me erase that. So I could have chosen that point. So this is the ordered pair to the right 4, which is your x, and up 2, which is your y. Remember, although the constant of proportionality or the unit rate is y divided by x, the ordered pair is x and then y. They're opposites of each other, okay? You don't put y divided by x and y and x, y then x in an ordered pair. Y divided by x is for the unit rate or the constant of proportionality. The ordered pair is x and then y for the coordinates. All right, so now, if I take this and divide it, the y is 2, so 2 divided by 4. I can divide them both by 2. And I simplify, I get 1/2, okay? Okay, but you didn't have to choose that one. I'm just showing you could have chosen a different one. So now, what if I choose this one? We would have chosen that one. Then that's the ordered pair, 6 and 3. So if I were to take that y and divide it by that x, I would end up with 3 divided by 6. I could have simplified, divide them both by 3, and I get 1/2. And if I were to do the last one, that's a bad 1/2. Guys, it's not me. 1/2. Okay. If I were to work that last one right here, I would also get 1/2. I'm not going to work it though, because I think you all get the idea of what I'm talking about. So I know K is equal to 1/2. Now 1/2 what? Well, keep in mind, you're talking about miles and then you're talking about hours. So it's going to be 1/2 miles per hour. So somebody's walking speed is a 1/2 mile per hour. They can go a 1/2 mile every hour. Pretty slow. All right, but that's the idea of graphs and finding constant proportionalities from the graphs. So again, a graph is only proportional if it's a straight line and goes to the origin. And you can find the constant of proportionality 2 ways from a graph. You can look for an x coordinate of 1, and that y coordinate becomes your constant of proportionality. Or the second option is to take a y and divide it by an x after you pick a point. Pick a point, divide y by x, and it will also give you the constant of proportionality. All right, that's that, guys.